let's continue looking at relation functions and graphs. Let's look at graphs right now. Now you have two main types of graph in terms of how they are categorized. Two main types of graphs to study. One is linear and the other non-linear. A linear graph will produce a straight line. Alright? So the linear graph will produce a straight line, while the nonlinear graph will give you a curve. Now, I know that some mathematicians refer to the straight line as a curve as well, right? But for now, we have our straight line and we have our curve. So we have our straight line, no bending, and then we have our curve. Could look like this. Our curve could look like this. It could look like this. As long as you have it bent, that's a curve. Now, a graph, when you plot a graph, you should have a title for the graph. For example, we could say the graph of y equal x squared or whatever it is, or graph showing one quantity changing with another quantity, or graph of temperature versus time, whatever the case is, right? You should have a title telling you what, or telling somebody else who's looking at the graph what the graph is about. Then you need a scale for the graph. The graph should have a scale, right? Now, what that means, for example, on our graph paper here, let me increase the size of our graph paper and to make it a bit bigger. Suppose you have some numbers, right? And let's say you have this line, horizontal line, which you call your x-axis. This is your x-axis. It's horizontal. It goes across, right to left, left to right. When you're looking out to the sea and you look at the horizon, you see it go across like this. And then you have another line with values on it, which you call your y-axis. So, y. These are the two axes on which you will have your number and your scale. Alright? Depending on the values, the x-axis could be down here, it could be up here. The height of the x-axis will depend on how convenient it is to place the numbers on it, as well as the position of the y-axis. Depends on how convenient it is to place your numbers on it. Where the x and y-axis cross each other is called the origin. Right? We soon come to the scale. When we put on the numbers, we'll talk about the scale. The origin. Now, here you normally have 0, and then you have the other numbers. For example, if you have the origin here, let me just erase this here, this number. You have the origin right at this point, 0. Each division with a thick line. If you look at your real graph paper and you take your ruler and place against it, you will see that they are 1 centimeter apart. Each of these thick lines is 1 centimeter apart. Alright? And if you say this is 1, well, negative values go to the left of 0, negative 2, negative 3, negative 4, negative 4. You're putting on what I call your units. 1, 2, 3, 4, 5, and so on. These are your units. Right? Now, you generally write these unit numbers below the x-axis. Let's look at the y-axis now. Again, if you put your ruler against a real graph paper, you see that these thick divisions here are 1 centimeter apart. 1 centimeter. Then you can put your numbers here, 1, 2, 3, 4, 5, and so on. These are your unit numbers. Now below 0 are negative 1, negative 2, negative 3, negative 4, negative 5, and so on. Alright? And generally, you put your unit numbers to the left of the y-axis. So, at the center, not necessarily at the center of the graph paper, but at the origin, where all the numbers originate, the measurements originate from, to the right along the x-axis are positive numbers, to the left along the x-axis are negative numbers. Above 0 on the y-axis are positive numbers, below 0 on the y-axis are negative numbers. And these numbers you call your unit numbers. Now I have put my 1 centimeter from 0, then my 2, another centimeter, make it 1 centimeter from 1 or 2 centimeters from 0. My 3 is 1 centimeter from 2, and so on. So the measurement or the space between my units is 1 centimeter. So every 1 centimeter I go, I have 1 centimeter unit. So my scale here on the x-axis, I have put 1 centimeter equal 1 unit, because every 1 centimeter I move, I put 1 unit. 1 centimeter, I put 1. 1 more centimeter, 1 more unit, making 2. 1 more centimeter, I put 1 more unit, going from 2 to 3, and so on. And the same thing happens on the left side, on the negative side. 1 centimeter, negative 1. 1 more centimeter, negative 2. 1 more centimeter, negative 3, and so on. So, on the right, 3 centimeters from the origin is 3 units. 4 centimeters from the origin is 4 units. 5 centimeters from the origin, 5 units, and so on. Now on the y-axis, I have put above 0, 1 centimeter above 0 is 1. 2 centimeters above 0 is 2. 3 centimeters above 0 is 3. So that every 1 centimeter I go, I put 1 more unit. So 1 centimeter up, 1. 1 more centimeter up, put 1 more unit to make 2. 1 more centimeter up, I put 1 more unit to make 3. So every 1 up, 1. Another 1 up beside 2. Another 1 up, 3. Another 1 up, 4. Another 1 up, 5. And so on. So on the y-axis, I also have 1 centimeter equal 1 unit. So that's my scale. But depending on the numbers, I might use a different scale. Let me erase these. Suppose, for example, I am going from 0 to 5 on the right and to negative 3 on the left. Instead of saying 1, 2, 3, 4, 5 and leaving out all of this space here, I could make better use, more efficient use of the graph paper. So I put my 1 here, 2 here, 3, 4, 5. And the bigger the graph, the more accurate it is. So might as well I use up the space. I have what I said was from -3 to 5. So I have -1, -2, -3. And I'm making good use of the graph paper now. So on the x-axis, my scale has changed. So let me make that adjustment. What is the unit? What is the scale that I'm using now? I go 1, 2 centimeters, and I have 1 unit. I go 1, 2 more centimeters, and I have another unit. So I'm using 2 centimeters for 1 unit here. So 2 cm equals 1 unit on the x-axis. That's my scale. Suppose on the y-axis, now I have, say, I'm going up here to 30. Then I would say 5, 10, 15, 20, 25, 30, and keep going up. Now on the y-axis, because I have such large numbers, it would make sense for me to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By the time I reach 30, I would be well off the graph paper. So I have to compress these numbers to fit on the graph. So what I'm doing is making 1 centimeter, I have 5 units. 1 more centimeter, I have another 5 unit making 10. 1 more centimeter, 5 more units on the 10 making 15, and so on. So on the y-axis, I'm using a scale of 1 centimeter equals 5 units. All right? 1 centimeter equals 5 units. Now, in some graph, the unit might be specified. For example, if I collected stones and I'm measuring the mass of each stone in grams, then if this on the y-axis is in grams, then I would write that my scale is 1 centimeter equal 5 grams. All right? So you fit the scale depending on the size of your numbers or the size of the units. Now, we want to, that was accidental, we want to show a certain point that we plot. Let's say we want to identify the point where x is equal to 1 and y is equal to 15. Generally, how this is written, instead of writing down x equals 1 and y equals 15, you do this: 1 comma 15. The general way it is written is x comma y. You have curved brackets, a comma in the middle, and on the left you have the value representing x, and the y on the right you have the value representing y. Never switch them around. It's always x comma y. So 1, 15. Now to identify when x is 1, you move along the x-axis until you see 1. Then you want the corresponding value 15. You go up to 15, but make sure you're in line with 1, and you see 15 here. So you identify this point here. Don't use a dot to identify that point. What you do is use an X to identify the point. So you plot the point. In some cases, you could use a dot and a circle, right, to identify the point. Whichever way you want to do it. I like using an X. Could use the X or the dot and the circle. Those are the most popular ways to identify a point, right? To plot a point that you're identifying. Now, you may also want to plot 225. So you identify or you plot the point 2,25. You look when X is 2 and Y is 25, you go up to 25 and you plot that point. You want to plot the point -3, -20, or -25, or 30, whatever it is. Let's put the negative values on the y-axis here. -5, make it a bit thicker. -5, -10, -15, -20, -25, -30. Say we want to plot the point -3, -30. We have X is -3. We go to where -3 is and go down to -30. So make sure the point is below X is -3 and beside X is Y is -30, and you plot the point right here. Alright? So we have 3 points plotted. This point is 1,15. This point is 2,25. This point is -3, -30. Alright? So you plot the points like that. Now, let's look at one more thing before we end this video. I want to increase the size of the graph some more. Here now, let's look more closely at the markings on the graph. As we saw before, we have the thick marks. 1 centimeter apart. So you have, if this is 0, this would be 1 centimeter. 1 cm. This is 1 cm. Right? Go out further, you have 2 centimeters, and so on and so forth. Now, this here is 0. Between 0 and 1, you have 1, 2, 3, 4, 5 thinner lines. 1, 2, 3, 4, 5. Now, each of these divisions is 1/5 of a centimeter, which is the same as 0.2 centimeters. So it's 0.2 centimeters. We have 0.2, 0.4, 0.6, 0.8, 1. Alright? So this is at 0.4, 0.6, 0.8, and 1 centimeter. Now, if you're plotting and you have to look closely at the graph, 0.1 would be halfway between 0 and 0.2. Suppose you have to plot 2.5, say 2.5 centimeters. You would have to look at 2. You know that this is 3 centimeters. So 2.5 would be halfway between 2 and 3, which would be this. Alright? If it is a case where you're supposed to plot 2.6 centimeters, then you get 2, let's see, 0.1, 0.2, no, 0.2, I mean 0.4, 0.6. So this, above this, is where you would plot your x value as 2.6 centimeters. So this becomes useful when you're plotting a graph or you're drawing a histogram in statistics. You must be able to identify the fractional values of one whole centimeter or one whole unit on the graph. All right. So, say for example, you have 0, 5, 10, 15. So you're using 2 centimeters equal 5 units. Notice this is also 1 centimeter is equal to 2.5 units. But generally you don't use the fractional values like 2.5. You don't bother to use points when you're writing down your scale. So this scale would be 2 cm equal 5 units. Suppose you want to identify exactly where 5.3 is. Now in this case, you have 1 centimeter. 2 centimeter equal 5 units. You have between 0 and 5, how many divisions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions. So each division represents 1/10 of 5. It's 5 divided by 10 parts. So it is 0.5. 0.5, 1. 1.5, 2. 2.5, 3. 3.5, 4. 4.5, 5. You see that? So you want to find 5.3. You know that you pass 5 and each division here represents 0.5. So you have 5. 5.5, 6. No, 5.5. Not 6. You don't read 6. It's 5.3. This is 5.5. Because each division is 0.5. Now, exactly halfway between this and this is 0.25. So what you do, find halfway and go to a little bit to the right. And right up here, right along here, is about your 5.3. Right? So it's really an estimate of where your 5.3 is. And if you want to identify, let's say 5.6, you have 5.5, all the way out here would be 6. But you don't read 6 yet. You are at 5.6. So you are 5.5 and go a little bit to the right. An estimate shows you a little bit to the right of 5.5 is 5.6. Alright? So it's just a matter of properly estimating where you are on the graph paper. Alright, what we'll do in the next video is look at linear graphs. That means graphs of straight lines. So I will see you when that time comes.